Hello everyone. Let's look at the problem average, equal average partition. So, what is the problem? So, we are given an array A, like here 1, 7, 15, 29, 11, and 9. So, we have to partition this array into two parts such that this array and this array have the same average, right? So what will be the property? Let's say this sum is S1, this sum is S2, and we know the total sum S equal to S1 plus S2, which is the sum of elements of the array. So let's say this in this array n1 elements are there, and in this array n2 elements are there. So if the averages are same, then this equation is valid. S1 by N1 equal to S2 by N2. And if you look carefully, that in turn will be equal to total sum by total number of the elements, let's say n. Uh, so, uh, so if the average of two arrays are same, then we can say that if one subarray has sum n1, s1, and number of elements are n1, and is equal to s by n, then we can safely say that we can divide the array. Okay, so this reduces to a well-known DP problem, which is find if some of the elements to a given sum exists or not. So let's see how we can do that. Yeah. So the given sum is let's say the given sum is s this one, and number of elements we are choosing is n1, and total sum is s, and total number of elements of the total array is n. So first of all we have to check if this pair exists or not. How do we check it? So we have s1 by n1 equal to s by n, right? So and s1 should be integer. So if s into n is like divisible by n, then we can say that s1 is integer and it exists. So okay, so if we have this pair s1 and n1, so how do we check? So we can what in this array, our function will our dp function will take our vector. Let's say we have some current sum, number of elements n1, and index. So we will be starting from the index 0, and we will have to check if this element is to be chosen or not chosen. So if we choose it, then we will pass into the function that v s1 minus v index, and this will get detected 1, and our index will increment. And next we will not select the element, so we will get one boolean for this thing, one boolean for this thing. So these results will be stored into a map for caching. Okay, so and in the question we are also given that give we have to give the smallest we have to give this smallest array like we are doing two partitions, right? So this array should be smallest if multiple answers exist, and that too we have to give that we have to give the smallest logical order. For that, what I am doing is, before when we are in the starting of the function only, I am sorting the array. So what this will do is this will ensure that we are getting the so smallest lexicological order. And after that, when like we are finding the condition for Sn pair, S1 N1 pair. So for that, when we will, so this is the loop. So this is the loop. In this loop, what is happening is we are checking if S like this, that kind of pair exists. So if it is divisible, we'll find the function for this is our vector. This is our number of elements in our subarray. This is our sum in our subarray, and this is our index. So after that, if such, so whenever we will find the first occurrence, then that will be giving us the smallest subarray of the that will be giving us the small subarray, because we are traversing from I equal to 1 to like n minus 1, right? So in that way we can ensure that we are giving the smallest, right? Thank you.